So I just wanted to point out something I didn't go over last time, and that's whatever is inside this radical here is inclusive. You can't add something to it. Whatever's under it, that's it. You could separate it by multiplication, but you can't add to it. So this wouldn't be the square root of 30. This is the square root of 25 plus 5. So, we didn't do any equations last time, but I just wanted to show you that this would be 5 plus 5, and that would equal 10. It wouldn't be whatever the square root of 30 is. I don't know what that is. It's not a perfect square. I mean, you can still take the square root of it. You can take the square root of any number, but it'll be irrational if it's not a perfect square. But yeah, we'll do another example just so you're clear on that, and we'll move into the next topic, which is taking square root of non-perfect squares like 30. Yeah. So going back to where I left off last time, I just wanted to show you that the square root is inclusive. You can't add to it. This plus this does not equal this. This plus this actually equals 10. I showed it in the last example. So let's move on and try some other ones. This isn't equal to the square root of 200. You can't add these together. They're two different numbers. Like I said, inclusive. This is just 10. We know the square root of 100 is 10 plus 10. And that's equal to 20. So that's the answer to number 1. Number 2, like I said, inclusive. You can't subtract this. This is not equal to, so that not equal, I made that clear last time, but that's what I meant. Not equal to the square root of 0, which would be 0. This is actually equal to the square root of 25, which is 5, minus 25, which would give you negative 20. So those are the answers to those two. So I'll say it again. I just want to keep repeating it just so it's driven into your head. This is inclusive, so tell me what this is not equal to. If you said this is not equal to the square root of 25 or 5, then you are correct. But you may be asking, well, how do you take the square root of this? Well, this isn't a perfect square. No two integers times itself equal 20. But you could think, well, the square root of 25 is 5. Square root of 16 is 4. So this number's got to be in between 4 and 5. So clear this up, and we'll solve for the square root of 20, and then we'll, tack on 5 to that. But I'll show you how to do that. It's a little bit different than what we've been doing. Same problem implicitly, but a little different. So we'll clear this up, and we'll get back to that. We want to solve for the square root of 20 plus 5. Now, I don't know what the square root of 20 is off the top of my head. It's not a perfect square, like I said, so... But there are ways to solve for this. I mean, we've been doing this implicitly. You may not know it because you just know, oh, hey, 5 times 5 is this, 4 times 4 is this. But we've been doing this implicitly. I'm going to show you how. Don't worry about this part for now. We'll do this later, but let's just put this off to the side. Well, the first thing I want to do with this, since it's not a perfect square, is factor it. And you're probably asking, well, why are we factoring it? Well, we do this for all of them, like I said, implicitly, but you may not notice. I'll show you. So 25, let's factor that. We want the square root of 25. So we'll take 25, and we'll factor it. Oh, what do you get? Well, 25 is only divisible by 5 and 5. So, well, we know that's 5 squared, right? So if we were doing this, we'd say, okay, let's do that for 25. But since it's under the radical, like I said earlier, it can't be separated by addition, but it can be by multiplication. So this is root 5. And this is root 5. And what's the square root of 5 times the square root of 5? Well, or it's the same thing as saying, what's the square root of 5 squared? Well, don't forget, this undoes an exponent too. So the exponent 2 must undo this, so the answer is simply 5. And you can see 5 is obviously the square root of 25, so we just proved that that works for this. So now we're going to take a look at doing it for a number like 20, which isn't a perfect square. So I'll erase this, and we'll set it up, and I'll show you how to do that. So getting back to this problem, like what I said was we like to factor this. So let's factor 20 before we even do anything with the radicals. And we'll see that 20 factors into 5 and 4. And we like that because, when you're factoring, you want to factor it to prime numbers. Like you want to get every factor into prime numbers. But it's great when you factor it to have a number like 4, which is a perfect square, because when you factor it now with the radical, you'll say, okay, look, this is the same thing as radical 5, or root 5, sorry, they're interchangeable, so they don't really matter how you say it. Square root of 5, radical 5, root 5, doesn't really matter. Well, this is just 2, and this can't be reduced anymore. You can't lower this anymore. If you could, you would factor it a little bit more, but you can't, so this is just root 5. Now, like I said, this can't be moved through addition, but it can be through multiplication. So this right here, we'll write it the other way. I'll have to have the radical out after the constant, is the solution for 20. The square root of 20 is equal to 2 root 5. That's right, 2 root 5. So the solution to this problem would just be 2 root 5 plus 5. This is not 7 root 5. That's not true. That, like I said, these can't be. These are two numbers being multiplied. This is a number right here. 2 root 5 is a number. It's an irrational number. But, so this is a different irrational number. So they can't be moved, but this is the solution for that. Just grab a calculator and we'll get approximate answers. This is the exact answer, but we'll get approximations, and I'll show you that square root of 20 is the same thing as 2 root 5. So here I'm just going to show you that these numbers are equivalent. I'm just going to get an approximation. You could do this too on your calculator if you like. You just plug in the square root of whatever. So that's the square root of 20 is equal to 4.472 135, it goes on for a while. It's irrational, but let's go there. Now I'll just look at this, 2 root 5, and look at that, gives us the same exact answer, 472, yep. Now you just add 5 to that, and that'll solve your answer, which is 9.472. Okay, that's the answer to that problem, by the way, root 20 plus 5. If you had to approximate it, you could just leave it at like this, 2 root 5 plus 5, if you don't have to approximate it. Now I just want to show you why this is not the same thing, why you can't add them. When you put 7 and multiply it by root 5, 7 root 5, that's equal to 15.652. 4, it goes on forever, but these are obviously not equal, so that would not be the right answer. So that further proves that this cannot be separated by addition, but it can be by multiplication. So we'll do 1 or 2 more problems, and then we'll just call it a day. But I'll erase this, and we'll continue with the problems. So we have 4 problems here. I'm gonna list them. But here's 1, here's 2, and here's 3 and 4. I'm just gonna go over 3 and 4 real quick. Like I said, the first thing you want to do is factor them, and the thing with 4 is it's root 7. 7's a prime number. The only thing that comes out of 7 when you factor it is 1 and 7, so it's prime. So if you ever have to solve for this, just leave it like this, root 7, and if you have to approximate it, just plug it into your calculator and you'll get root 7. Now, root 6 is a little different. The same, when you factor this, you're gonna get root 3 and root 2. These are both prime numbers. Their only factors are prime. They're like, 6 is not a prime number, but when your only factors are prime and they can't be reduced, then this can't really be reduced either. So if you get that, if this problem is solved, it's the same thing. It can't be reduced. So this would just be root 6, and you have to approximate it. You just put it into your calculator. But so we'll go over these two. Let me just erase this real quick, and we'll go over 120 and negative 24. I hope you didn't forget how to do imaginary numbers now. So first thing you want to do here for root 120 or square root of 120 is you want to factor it. Obviously, that's the first thing you do technically with all of these. So what does this factor into? Well, it factors into a couple things actually. But let's go with 12 and 10. Now 12 can be, you take the square root of 12. You can't really have 10. 10 goes down to 5 and 2, square root of 5 and 2. So that's just like 6 and 7 stuck there. 12, however, goes down to 4 and 3. So you take the square root of this, You take the square root of this, and you will get 2, and then you'll get square root of 3, and you get the square root of 10. Now, obviously, this is not how you write that, but like I said, you could combine these two with multiplication, and you'll get 2 root of 30. Now, let's check that. Let's see what that approximates to. Let's see. 2 root 30 is equal to 10.954445, you know, goes on. It's irrational, obviously, not a perfect square. Now, let's see what square root of 120 is. And I mean, square root of 121 is 11, so, you know, this is going to be very close to 11, I think so. Take the square root of 120, and you get the exact same number. So, now, this is the approximation, and this would be the exact answer right here. It's exact, that's approximation. This one's more correct, but they're both right, depending on what you have to answer. Now, I hope you didn't forget how to do imaginary numbers, so let's just do this. Same way, factor them, but obviously nothing, no integer, or any number for that matter, times itself will give you a negative number, so just pretend that's not there. Let's just go like this. We're not going to factor that, obviously. We'll factor this, though. And what do we get? Square root of 4 and square root of 6. And like we said, 6 can't be reduced, but 4 can. 4 is a perfect square, and you get 2 root 6. Is this right? No, it's not right, because that's the square root for 24. We want the square root for negative 24. So don't forget the I to denote that it's imaginary. Now, I don't think it matters where you put the I like to put it after the constant, but this would be correct. 2I root 6. That would be the answer. The I denotes that this is imaginary, and that's the answer for 2. So, yeah, but, yep, that's how you solve radicals for imaginary numbers and radicals for non-perfect squares. And obviously, you know, this is a non-perfect square and imaginary number. So, yep, that'll be all.